Hey, good morning, everyone. This is Mahesh from Vayu Robotics. I'm one of the co-founders, and I'm also the Chief Product Officer of my company. I'm very happy to share what we are working on. Our vision is to bridge the gap between the world that we want to live in and the world we are in now. And our vision is that in maybe 100 years from now, probably deliveries will not be made by human beings, but probably be automated by using some form of robots. And we are trying to work towards achieving that vision of ours. So there are a few people in my team that I would like to highlight. And they are my co-founders and friends from my previous job. One of our CEO is Anand Gopalan. He was the former CEO of Velodyne as well, and he took the company public. My other CTO is Nitish Srivastava. So he was the inventor of dropout, which is a technique used in almost every neural network today to minimize overfitting. And he's leading our AI and ML efforts. And he was my colleague at Apple for a few years when we used to work on the autonomous systems group. And we have some advisors to the company. One of them is Professor Ramesh Raskar. He's a leading computational imaging researcher. And we also have Achyuta Kedambi, who was a grad student in Professor Ramesh's group when he did his PhD. And with this team and a set of around 12 people now from various places like Amazon, Facebook, and other robotic companies, we have set out to do what we are trying to do. So I'll start off by stating the problem statement. So typically, there are a lot of, like, if you look around, there are maybe 20 to 30 robotic startups which are trying to do this delivery of goods from point A to B. And fundamentally, we believe that they either fall along the sidewalk bot category, which is small and drives slow, or they fall along the neuro category on the other end of the spectrum, where they are big and they're almost trying to solve the autonomous vehicle problem. So there are two key challenges with both these approaches. For a sidewalk bot, most of it is teleoperated, and sidewalks are highly unstructured environments. So what ends up happening is it almost is teleoperated for majority of the time. And the data that goes in from the bot and back into the bot using a remote controlled operator is very high. So the cost of data, which is shown in this green plot, a green color, is very high. Whereas on the other end of the spectrum, you have neuro, which is a very expensive vehicle. So the cost of the vehicle is around 100K per vehicle because it needs expensive compute and sensing. And in order to break even, they would need to charge a cost of like $2.5. And what we are proposing is a bot where the unit economics actually holds good if the technology checks out. So in our approach, we are trying to hit a BOM cost of less than $5,000, and we have proved this to ourselves by building a prototype. And this would result in a delivery cost of less than $1 per mile. And we are able to do this by using a couple of key technology differentiations. So we are developing a very low-cost sensor technology, and we are also developing an AV stack, which is based on attention-based reinforcement learning. And our intent is to make deliveries within 15 minutes for under $1. And the form factor of the robot is intended to be like a bicycle. So basically, the momentum of the robot is expected to be like a bicycle, so that the safety barrier is much different compared to a neuro. And the weight of the robot, including the payload, would be less than 200 pounds, and it would go at the speed below what Usain Bolt would do in a 100-meter dash. So basically less than 20 miles per hour. And like I mentioned, we have two key pieces of technology, which is 3D sensing and the AV stack. The 3D sensing exploits aspects of the light field, which are currently not exploited today. So there are intensity, wavelength, oscillation of the electric field, and a few other parameters, which we are exploiting to get more information about the world around us. And on the AV stack, we believe that the mobility task, the intelligence needed for mobility task, is not necessarily learned in the real world, but it can be acquired in simulation. And we do sim to real adaptation by using some new techniques that we have developed in our lab recently. So here is our product concept. So I just wanted to show you, end by showing this to you. So this would be typically loaded in a grocery store or in a supermarket or a pizza shop or things like that. And it would drive by itself into a bike lane, as you can see, and it would have the intelligence to traverse around obstacles, as you can see, trash cans, and go and deliver goods on the driveway of the house. So that's the concept that we have thought of, and we have made significant progress in minimizing some of the technology milestones that we had. And and in terms of partnerships, we are definitely looking for corporates who are interested in pilot programs to enable to use this technology, not just in the final form factor, but also in parts such as sensing, drive stack, or users in indoor environments and things like that. We are also looking for partners on the hardware side for technology development who have expertise in that. And we are also definitely interested in some customer traction to work with us to define the specifications and so on. So that is, that is our company. Please feel free to ask me any questions. I just wanted to end by saying thank you for listening to us. And my email is mahesh@vayurobotics.com. Thank you.
Thanks, Mahesh. Great. So first question is...
Yes. What about, yes. So
Yeah.
we have use cases of our sensing technology on in indoor environments. So we are able to, for example, in logistics, you would see a lot of shiny surfaces and glasses and metal objects and things like that. So our sensing technology is able to do things which a regular sensor cannot do. So like I said, the delivery is our North Star, but along that path, there are various other monetizing opportunities, and indoor logistics is something we are definitely interested in. Do you plan to? Yes. So regarding the second question, do you plan to deliver goods at the door or to someone? We have both approaches. Like you saw in the video, a lot of the blockage in the current model is that once the robot gets to the desired location, it has to wait until someone comes in, and that creates a lot of issue in terms of bad planning the operations of the robot. So we have an unloading and loading mechanism, which I briefly showed you during the video, that we will have to drop off the goods in a safe location, like a DoorDash person or an Uber Eats person or anybody doing grocery delivery does today. How far can it go?
That will be the last question. We need to move on.
Yes.
Just very quickly, how far?
How far? It can go up to 70 miles. We are open to designing the specifications to whatever our customer needs are, but currently we're thinking of having it work up to 70 miles. And how can you avoid robberies? I believe that there will always be some people who will do things which we don't desire. So we have to just budget for it in our business model. But in general, I believe that if there is something which adds value to humanity, people would respect that and not damage it, is my belief about humanity in general. Thank you.
Thanks, Mahesh.